Hi, my name is Mark Briscoe, and I'm a product marketing manager with Tektronix. In this demonstration, I'm going to show you how you can use a 6 Series MSO to identify and analyze signal anomalies in a mixed signal design. In this demonstration, I'm using an MDO demo board and an MSO 64 mixed signal oscilloscope. I have a TPP1000 analog probe connected to the channel 1 input on the scope, and the other end connected to the frequent anomaly test point on my demo board. I'm going to start the demonstration by starting the acquisitions, pressing default setup, and then doing an auto set where the oscilloscope will actually do an automatic setup based on what signal it sees on its input. And you can see here we have a 3-pulse burst. Now the signal's jumping around a little more than I want on the screen, so I'm actually going to use a feature called hold off by time, which is part of the trigger system, to be able to get a stable waveform. I'm going to do that by opening the trigger configuration menu, tapping the mode and hold off and saying I want to hold off by time, and I'm going to hold off by 600 nanoseconds for this particular trace. Now you can see that I've got a nice stable waveform on screen. It looks like a very well-behaved waveform, but I suspect something's going on with this waveform. So I'm going to use the FastAcq acquisition mode on the oscilloscope, which is designed to optimize the scope for fast, high-speed waveform capture rate, increasing the chances of catching any infrequently occurring signal anomalies. I'm going to do that by pressing the FastAcq front panel button. And you can immediately see we see a couple of different anomalies on this particular trace. There's a negative going glitch on the first pulse and a short or runt trace pulse on the second pulse. Now for this demonstration, I'm going to isolate that runt pulse, and I'm going to do that using the trigger system. I'm going to turn off FastAcq now because its job is done. I've seen that. Now I'm going to use the trigger system to isolate it. I'm going to select a runt trigger, change the threshold here, upper threshold to about 2 volts and the lower threshold to about 1 volt. We should start triggering on that waveform, and we do. So I can isolate it now, but it doesn't really tell me a lot about how often this is occurring, what kind of problems it's causing in my system. So I'm actually going to acquire a much longer window and use the automated search capability of the instrument to determine just how often this particular trace occurs. I'm going to hit the single sequence button just to gather a single acquisition into memory. And I'm going to use the automated search functionality to actually find all of the runt pulses in my waveform acquisition. I can quickly set up the search, since this happens to be exactly what my trigger is defined as, by hitting Copy Trigger Settings to Search button. And immediately we can see little purple triangles show up at the top of the display indicating where each of the runt pulses are that it has found. And it has found 7 events. Now I could use something like cursors to go in and measure the time between those pulses, but I'm going to use a little bit different technique. And it's called a search results table. And I'm going to do that by hitting the Add New Results table, selecting Search, and saying Add. Now the search results table shows me an index of the 7 events that it found, as well as the absolute place in memory relative to the trigger point and the delta time from the prior search event found. And so here I can see that they are occurring about every 3.3 milliseconds. You can't analyze what you can't capture, and you can't trigger on what you can't see. FastAcq is a fantastic tool for identifying, discovering signal anomalies in your trace. And advanced triggering can help isolate and capture those signal anomalies. Then you can use automated search to actually quantify each specific anomaly in each acquisition.